Mark Nijhof, will be talking on the command and query responsibility segregation and the sample application that he created for it. Mark?
Hi Jan, thanks. Indeed, I'd like to talk about the command query responsibility segregation pattern principle design something that I got from spending quite a bit of time with Greg Young while he was here in Bergen. This was a very interesting time, and because I wanted to look and see how this went, I decided to create an example application, and that grew rather large, and I decided to share that, and that was well accepted. Hence this presentation that I'm holding now for the event. First, I just started blogging on Elegant Code. They invited me. So if you want any future posts about this or want to make comments, then leave them there. You can leave them on Twitter as well. And if you want to download the source code, you can find it on GitHub at the following address. I'll show this on the end of the presentation again. This is the same image you found on my blog. I want to show, talk a little bit about how this architecture is before I go into the code. I'm not sure if everybody knows this. It's very new. The thing here is that Greg has taken command and query separation up to a higher level. Instead of applying it at a class level or even a method level, he is applying it at the complete architecture of a application or system. So when we look at this image here, we can identify a few areas, which is the database area. Actually, I have a nicer one. Oh, sorry. We have a read database. We have the client. We have the domain as we know it. And we have some medium transport between the read database and the domain. And this is what command query separation is about. You separate the read side from the write side, the domain where the behavior lives. So your domain can be completely write only, so you won't be reading anything from your domain. You won't be querying it, you won't be asking it, you will just tell it to do stuff. Okay, execute this type of behavior, that sort of things. On the database side, on the read side, there our database might look exactly as how we are used to a database looking, meaning pretty much a copy of your domain model. But in my example, I chose for a different approach, an approach that Greg recommends, which is to optimize your tables for its particular usage. So your tables will try to mimic the exact data needs for each screen, for example, in your application. So if you've got two screens, one screen, which I'll show you later, showing clients, and then a next screen showing client details, normally we would have just one table for that and do a specific query. The approach that I'm choosing now is that I have two tables. One showing only the minimal data that I need to show each of the clients, and the other one has actually all of the client details in it. This would speed up your querying quite a bit because you're not going to actually do any fancy select statements to get your data out to the client. There is a bit more overhead in how you populate. Constraint is likely to be less than actually querying the specific data. I wanna talk today in sort of this sequence. I want to quickly look at the read database, although I don't think this is that interesting. I want to take a look at the client and how it sends commands. Then I want to take a look at the domain, and finally about how the domain actually brings itself in sync with the read database again. So if that's good enough. Oh yeah, by the way, if there's questions, send questions to the questions and answer board on the live meeting. If I miss them, then Jan has agreed to actually just ask them for you to me. So just jumping whenever. I think that is a nicer approach than waiting until the end and then doing some questions, because now it's all fresh if you look at it. So yeah. So first the data part. No, let's first. Sorry, let's look at the actual application, so you get an impression what it is actually doing. Press F5. It's running, but I don't see anything coming. Ah, it's behind something else. So as I said, this is a small application where I have clients who have accounts. It's a sort of a bank management application, whatever. And each client can have multiple accounts, and each account can have money transfers. So if I look at this screen now, you see that there's only really a client name and an ID. I need an ID in the background, of course. So my view on my database for this screen only has these two columns. Now if I click on there, then I open up this details screen, and here you can see there's quite a lot more details. There's the name, the phone number, the address, the accounts, and which closed accounts this client has. So in this case, the table will have more data in it. Now I can do all kinds of things. I can, for example, create a new account. You see now the delay, right? The delay is artificial, because what happens is, if we go back to here, is the client creates a command which is create new account or open new account in this case. The command gets sent to the bus, to the command bus, and will be handled by this specific command handler, which opens the domain, executes the behavior, and then fires off an event, and the event goes all the way to the read database. So what is special about this sort of is that the domain does not actually send anything back to the client here. It needs to go all the way towards the read database and then going back here. Now the delay is artificial because I've built in a timer which executes after 2 seconds and just refreshes the screen. So in that case, the new data has arrived. I'm using this all over. So depending on the latency you have in your screen, you can do this. If I don't put in the timer, it actually goes that fast that if I refresh the screen right away, then everything is there already. So, but for larger systems, you will probably not have that type of speed. Now, then I can open up the account. I can deposit some money. And here again is the delay. Now it's there. And I can do all kinds of things here. So I'm not sure if you've noticed, but the things here that the UI has is, for example, make cash deposit, make cash withdrawal, transfer money, or change account name. These are very specific things that I want to have. This is really specific behavior. Instead of saying account, change account name, or close account, let's take the client actually is a better example. The client here can change his name. We can indicate that he has moved, or we can change his phone number. So instead of just having a edit client screen, we have very specific input screens for the specific use cases, for the specific scenarios. So this is something that sort of this way of working brings with it. You wouldn't necessarily have one big screen of doing one update, because everything is very specific towards a particular command that you want to send to the domain. So I think that's for now at least the client, the actual application. It's, what's this? As I said, I have very typical DTOs here to do the transport from the read database towards the client. I have an account report which basically only has the ID, from which client this ID is, the account name, and the account number. It doesn't contain anything else. There is a little bit of logic here to make this easier to use in the UI, but that's all. Now, if we take a look at the account details report, you can see that we have quite a bit more, not that much more, but a bit, is we have actually our ledgers, our transfers. We've got the current balance, and we've got the account number as well. So this is extra information. Now, in the database, this means it's two different tables. Each DTO is basically an exact copy of the structure of the table that it is going from. I actually went this far that I can add a new DTO, add it and register it to my database script creator or whatever, and it will create my database table. All of my select statements and everything is also reflected upon this DTO. I did this in this way because I want to put focus on actually the CQRS implementation, and not so much about what type of ORM I'm using here. So I won't actually go much further into this. If you want to see how this works, I recommend you just download the source code and take a look at the reporting and reporting DTO libraries. This is the SQLite reporting repository, which basically has a get by example, and it's using the DTOs again. So I hope that this is clear enough. I don't think it should spend much more time on that. Now then we go to the application, which is a bit more interesting. The presenters actually. So let's take a look at the client details presenter. So of course. Okay, load data here basically goes to my my reporting repository and says get by example, and it's getting a client details report depending on a particular ID. And this is my client details presenter, so that's what I really want here. Now, the interesting part is, of course, when we start looking at our behavior. Here is a save new client name. If I want to change the name of the client, then I have a button which I can press, and this button will actually trigger this behavior. I'm not sure if I should open this. Do that again, takes too long. Anyway, anyway, this is something you can take a look at yourself. It's very simple WinForms application, and you click a button, an event gets triggered, and the event triggers some logic on the presenter. It's the MVP pattern that I've implemented here. Very simple and straightforward. Currently, my Visual Studio doesn't like me opening design forms. Anyway, let's say that this is being triggered. And then here is what is interesting. Here we actually tell the bus to publish a new command, which is the change client name command. And this command only contains the ID of the actual client and the new name that I want to assign. Now if we take another look at another command, here is the client is moving command. So in this case, we have the ID of the client, the street number, postal code, and the city. The interesting part of this is that it is only very specific about the thing that I want to change, the state that is the data that is needed to be able to make this state change, to be able to execute the behavior that I want to execute on the domain. Secondly, the naming of the commands are very close or should be almost identical to how our clients think about their process. So very DDD orientated. Now, then really this client is done. I mean, it has sent this command. I said something about I'm faking a refresh in 2 seconds here. So all that I'm doing after this again is reloading my my reports and seeing that the data has updated. Now there can be cases that you say, okay, it takes too long for this whole process to be around, and when I refresh my form, it takes too long for the data to be updated. I want this to be differently, and in that case you might want to implement a view model on the client side where you're actually updating the exact same state as you expect the domain to do, and then the client is being faked as he thinks it's there, he thinks it's done, but in reality it is just fake, and the domain behavior hasn't really executed yet. So something may have gone wrong, but since you faked it, he doesn't know until he comes back at a later time where you alert him about this. So I think that's also enough about the client, really.
Mark?
Yeah?
I've got one question from John Harold Torresdal, and he asks if you want to have a classic update screen, for example for the customer, would that make it more difficult to accomplish with the command query responsibility segregation?
If you have a complete update screen containing all of the fields, for example for a client in this case, then what you most likely are going to lose is the intent. Why did they update particular data, and why? What happened? What's the reason for the actual change, or the reason for executing the domain behavior is lost. Now it's not harder to do this. You just have a command that has more data in it, and then when you execute this on the domain, you need to update more data, or even maybe data that hasn't changed, or you need to make some logic that filters out unchanged data. I think the biggest loss here is purely the loss of intent, why something got changed. Because if you have the ability to update everything at once, then you lose the ability to say only this has changed because of this. Hope that is good enough explanation. So the bus sends out a command, and the command then gets handled. Let's take the client has moved, or client is moving command. That's one other thing. Commands are in the present time. something is about to happen, whereas events are in the past time saying, okay, this has happened. It's a good distinction so that you can say, okay, now we want to trigger this behavior, and we say, okay, this behavior has been triggered. Anyway, this is the client is moving command. This is very similar to a DTO, as we saw before. You may actually want to use some value objects here. I didn't do it because it makes serialization not that much harder, but it's just an extra step, and this is just an example. But it makes sense to put value objects there, be a bit more declarative. And
Mark, we have another question from Rob. As the domain and the system gets larger and larger, it looks like you'll eventually end up with many thousands commands and event handlers, etc. Is this right, or am I missing something?
No, this would be correct. You are getting a lot more of these smaller classes, but again, the thing that you gain is being able to tell why something has happened. You can use this information later on to, for example, get a new report. So let's say you've got a data warehouse where you're tracking a particular thing, but you haven't really been thinking about everything. So after the system has been live for about half a year, you get a question from the client and say, okay, we'd really like you to give us this type of information. How many clients after they have moved stopped being a customer at our bank? That might actually be very interesting information. In a previous scenario, what you have to do is then build some logging in there, or parse the log files that you've already got, and try to get this information. Now, if you don't have sufficient logging, then you can't say anything about the past. If you've got sufficient logging, then you can say something about the past, but it's going to be a real nightmare to get this information out of the system. If you're using these type of commands with their intent, and you have this as well in the events, then all you have to do is really replay all of these events, for example, and start acting on them differently into a different database where you're building up this report. And the great thing about it is that you're not just having a report from when you started doing this, you have a report actually from since the system got live. So yes, you're gonna have a lot of commands, and I would recommend organizing them in particular ways that make sense towards the application. You don't need everything as I have here in one commands assembly. You can make this organization much nicer. Another thing is that you can completely separate the command handlers, still going towards the same domain. So you can have two groups of commands and command handlers separated in assemblies because they're being used in a different application, but still being triggering towards the same domain. I don't know if that makes sense, but so I think you can deal with this in a pretty elegant way. Would that be good enough for an explanation? If we take a look at the command handler, which is here, this is really simple again. This should be very simple. It should actually not be doing much more than this one is doing now. I get the domain repository injected here, and then when I'm executing upon this specific command. And here I know what I have to do. So if this command gets executed, I should ask the domain repository to get me a client aggregate root using the ID provided by the command. And then on the client, I'm executing this domain behavior. And in this case here, I have my value objects. So if you would have them on the command, you could pass them in straight away. So this is the domain behavior that gets executed. And that's really all that's happening here. That's all what really should be happening here. I created a small decorator class for all of my commands, which basically wraps this into a transaction using a unit of work, and use some special registration logic to wrap each of my commands in a transaction. So this is something that you may want to do in a different way. The thing is that I can now, in my command handler, actually execute multiple different behaviors, and I actually found a bug here. The thing is that we don't do is actually...
Mark?
no, sorry, I refactored that. Yeah.
Mark, Jonathan asks, why don't you call repository.save?
Actually, that was what I wanted to say, that I found a bug here, that I'm actually not saving the repository. In fact, I made the repository, saving the client, sorry. In fact, I did a refactoring not too long ago, that is not needed anymore. What this get by ID is doing, it's registering the client aggregate that is being returned with my unit of work. So my unit of work knows about this client that has been requested. Now, in my transaction here, I do a commit after executing the command, and my commit in the unit of work, we actually look at all its registered aggregate routes and go by each one of them to check which one have actually changes, and then commit these changes to the event store. So I've kind of forgot about that myself, but so you don't really have to say save. You're going to have to say something else. For example, if you have a new aggregate route which is not known by the system, so it's not registered by the unit of work, then we need to add this item. So this comes back towards more how a sort of a list works, a collection. We only say, okay, give me this and add this, or actually I'm not removing, because I would actually never remove a aggregate route. I'll come back to that in a few seconds. So here I'm just saying add or get, and both of these actions will register my aggregate route to the unit of work, and then when I'm committing my transaction, all of the changes from these different things will be collected and will be pushed towards the event store in one go. If I, for example, trigger an exception here, then my aggregate route, then my unit of work would just roll back the transaction, meaning that all of these registered aggregate routes will be removed from the unit of work and will be restored in the previous state. So I think this is nicer than having to actually call save, because it's the unit of work pattern how this works. So I said I'm not removing any items from my collection, and that is because I don't want to remove them, because they are my history. One of the things that I didn't mention in the beginning, but I'll go back, is that the event store here is storing all of my events. We'll get there. But the thing is that my aggregates are also being built up by using these events. This pattern is called event sourcing. At least half of it. You're saving your events, all of them, so you can keep track of each individual state change. Greg then says, okay, if we have this, then we should also just use these same events to get back a aggregate route into the same state as it was when it was saved. So we're reusing these events. Now, the event store is write only, meaning that you can write an event there, but you can never or should never alter, delete, or insert new events outside of them coming from the domain. So you'd never remove an event. So I can't really delete an entity or an aggregate because the events are still there, and the logic is saying that if I request an entity with these events, an aggregate with this ID, then it will go to my event store, get all of my events with this ID, and it will bring it back the aggregate root in the same state. Now, the thing to how you solve this is that you would still have probably some kind of behavior which says, okay, account has closed or close account. The close account will trigger an event that the account is closed, bringing the account aggregate root in a particular state. That state is being saved here. So if you bring back that aggregate root, because of this state, you can't do anything with it. You get an exception or however you want to solve that. So that's one part of the problem. Now, your client would still see this account in this list. And in order to solve that is that the event will also be published here, that the client has been closed, an account has been closed, and this little piece of logic here that updates my reporting database, instead of setting it might actually just delete that row from this reporting database. For this particular account, because it's gone, right? The client has no reason of bringing it back. Now, if you want the client to be able to see historical accounts, then you will probably just put it into a different table or whatever. But the actually deleting logic, you are faking really again by not presenting that into the repository database. And since the repository database is the only way that you can actually get state or get information from your domain, your client doesn't know anything else than that it is actually gone, whereas the events are still there, because these events may actually be valuable. For example, going back to how many of our bank customers are closing their accounts after they have been moved. So this information is important to be able to get this data out of the system, but you don't want to display it anymore. Does that make sense? So, okay, so now we are actually, we have our command handlers here. I made a specific bus with the help of Jonathan, which does this in a pretty nice way. I would recommend you taking a look at this yourself a bit. The thing is that my first implementation was using a lot of reflection, and it was doing it every time a new command came in. Jonathan pointed me towards a way of doing that better, that now I'm only doing reflection on my initialization of the application, and I have a router basically indicating, okay, this command should go to this command handler, and this is being a static, a singleton, I mean, by the IOC that I use. Keeping track of this. So here, to be able to store all of the routes, I'm using reflection, but to actually execute my commands, my command handlers, I don't do that. Now, if you go for an actual bus, you don't need this, because N-Service Bus, Mass Transit, Rhino Bus, all will do this for you. So this is purely for my example to get that working. On the other hand, you don't want to start with an architecture with all of these buses and everything in place, because that might actually make it more complex than it is. You also will introduce additional complexity between your event store and your reporting database, because if you put in a bus here, and with queues you get to a point that you have that they may not actually be consistent with each other. When you start with a system like this, you probably don't want to bother with that. You just have these event publishers, events being handled by event handlers straight away in the same process, and only change this when you run into some performance issues. So then we have
another question from Rob. And I had a similar question posted on the user group. And I see you call them compensating commands. Usually I have understood that the term to mean something like undo rather than do. In other words, it compensates if something goes wrong. Is your use of the name compensating command actually meaning perform changes?
right. Okay. In this case, this is a problem with copy paste. Apologies for that. This command, this variable here should actually be named this way. But there is the notion of compensating commands and compensating events. Well, there's the notion of compensating events within the system. Let's say that you are indeed you're doing something, triggering a command gets handled in domain, and from that point on an event gets sent here, and in this case the event goes back to a service which then sends out the new command to do something else in another aggregate route or in another part of the domain, and you get an exception there. Now at this point there's no way of directly telling that this went wrong because this is not in the same transaction anymore. So at that point you need to trigger a compensating action. Say, for example, in my example, I can transfer money from one account to another account. This may fail, but when I send out my command from my client to say transfer money this amount to that account number, then the domain will do that. The domain will actually minus my balance with the amount that I want to transfer, and basically that's what's happening, and the event goes out here. Then the event goes back in the system, and a service is picking that. An event handler is actually triggering a service to pick that up. The service will check whether or not this account exists at this bank. Now let's say that the account does not exist. So at that point something is wrong because the amount has already been subtracted from my initial balance of my initial account. You may actually want to do that in a different way, but for the example that's what it is. So what you need to do at that point is you need to send out a compensating event or a compensating action back towards the original account. So you send out an event that goes back to a different service, or you do this directly depending what you want to do, but you are loading up the original account aggregate route, and there you're executing a compensating command going into the domain again, bringing back the balance to what it was. Now I can actually show that. Should learn not to do these things during a demo. Press F5. Let's just add a new account. In my example, every account, of course, is internally, and I don't have anything specific of going outside, except that I made a little bit of a trick in the money transfer service, is that randomly I reverse the account number, which results in a not existing account. So first here we see actually the money transferred from the account away. In this case, it looks like it actually went okay. Yeah. If I go and look at the other, oh, something went wrong. Okay. don't know what went wrong. But if this would have failed correctly, the thing that I would have seen here is another transfer back into the account for the same amount and indicating that the transfer failed. So these are two different events. They are two different things. So that's the notion of a compensating event and compensating commands. You want to be explicit about it. You don't want to just revert it and not saying what went wrong. That's again, by giving this a command and an event of its own, you can track these things much easier, and you can also see from the past what went wrong. And another cool thing about these events is that instead of just using them for your event store, you can use these events for anything. You can put up a different event handler that says, okay, I want to listen to all my failed transaction events, and if I see more than 5 a day or whatever your threshold is, I want to send an email to the administrator, or I want to do this and I want to do that. So you can use these events as they are used in an event-driven architecture, and just subscribe to these events and do something completely different. And the thing is that you don't put extra strain on your domain. You don't have to change your domain. You say, okay, from now on we also want to listen to these events from this event handler and do something else. The same with the reporting. If you get an extra reporting need, you create a new event handler. You bring the reporting database up to speed by replaying all of the previous events. And from that time on, the event handler is there and it will keep updating this new reporting database. So, but I feel that I really have to get into the domain now.
We have 2 more questions if you're up for it.
Yeah. No worries.
First question is from Rob. Do you think it would work well to load in new commands and handlers for version 2 and version 3 of the product using something like MEF? Would that take away the need to write reflection code in the bus?
Not too experienced with MEF yet, but since MEF can execute, I think it has an initialized method where you can do stuff. That should be not a problem, but the thing is that you're also going to need to change your domain, as I see it, because these commands and command handlers are specific to a typical behavior of the domain. In the end of the domain, you also want different events going out. So you could potentially do this for making it easy to registrate all of these things. And on the client, of course, you just need the commands and the bus to know, so you can be grouping your commands very specifically to your client. But in the end, if you just think, okay, I'm going to hook up some new commands by using MEF or by using whatever mechanism, so that I don't have to change anything else, I think that's will not be the case in reality, because you're going to have changes in your domain as well. Is that did I understand the question correctly?
We have 2 more questions, and Rob lets me know that the question was indeed answered. Second question is from Vitaly. Why I think it's a question about the schema. Why there isn't an arrow from services to command bus? Or you noticed services sends commands to the model.
Yeah, okay, here it means this was an early drawing which I have neglected to update, but I would imagine that your service would just push these commands in the bus again and have the bus deal with getting up the right command handler. You don't want to use a different mechanism for that, so he's correct in that sense. This is wrong.
All right, and then we have 1 more question before you can dive into the domain itself. It's from Podolak. How would you report an error to the user screen that is that this transfer failed due to any reason?
Depending on how you want to deal with this, say for example in the example that the code that I'm showing here, the error is actually reported because the error went through an event back to the reporting database, and the reporting database is displaying this error as one of the transactions. This is a very passive way of dealing with that. Depending on the transport that you have between the client and the command bus, let's say you've got something like VCF now, or whatever, but if you execute, you send out this command, it gets handled, and then an exception occurs here or an error occurs here that you want to notify the client straight away of. So from that point on, you can go back here, back to the client. I think you should see this as a okay, not okay communication. And another way is that you can use public subscribe here and just send out this event in there, and in that case you let the client listen to events as well. So these are different events than your domain events. But you send out the command here and you just let the client listen to commands using the same conversation ID, I think it's called in a service bus. So at that time the client gets updated. So I don't think this is, I think this wouldn't be much different than how you would normally do your error handling. The real difference here is that you wouldn't read out extra data from the domain, so you can't ask, the client can't say, okay, hey domain, tell me this. But you can, and when the client says, hey domain, do this, and that fails, then the domain is able to report that back to the client. That's not really an issue, as I see it. Okay. This is my aggregate root for an active account. I'm actually writing a more complete blog post about how this works, so if you want to read up on it later on, you can. But I'm using a base class here. I know there's many people who don't like using base classes, so I don't see a issue in just using composition for this as well, because the really important thing here is that the aggregate root implements this interface. This interface is used by the event store to get changes and to load the aggregate root back into its original state. So you have here get changes and load from history. Those are two main methods within this aggregate root regarding to persistence. Now, if we just take a look at this, and we go to one of these behaviors, take a little bit of a complex one. Withdrawal. So if I want to make a withdrawal from my account, I need to make sure that the account actually exists. So it's been created, and I need to make sure that the account is not closed. This is what is happening in my guard class. If any of these cases is true, then I'm throwing an exception, and in my case, since I don't use an actual bus, the exception bubbles up to the client again and will be displayed there at once. So I can't withdraw money from a closed account or a not created account. Where not created is an actual state within, both of them are actual states within the another behavior is that the balance needs to be high enough for me to make this withdrawal. Now, once I get past all of these domain logic things, indicating whether or not I can do something, and indicating what actually I can do or what I can't do, because there's no reason for this one only to have one type of event. I might actually want to have another type of event when when I get into a different path, but that is all up to you. So here, what I'm doing is I'm actually getting the internal balance of this account, and I'm withdrawing the amount from that balance, and I'm putting that into a local variable. This is very important. I am not updating the state of this balance here. None of my behaviors will update state. All updates of state will go through the event. So an event needs to be fired within the aggregate root, and that is then used to update the state. Now, this apply method, we'll go to that in a bit, but this apply method basically is a sort of a publish. You could say, okay, I'm publishing this event, and I have my new balance, and I have my amount. And, sorry. Here, in the initialization of the active account, I have register events, which is a private method, which basically registers each single event that this aggregate root can produce, and it registers a internal event handler, I like to call them, because these here handle whenever this event is being fired. So whenever I send apply cash withdrawal, then the apply method will actually trigger this event handler. And as you can see here, is that I'm adding a ledger to which is a transaction, and here I'm actually also updating the balance state. So I'm not doing any business logic or whatever. To take this a bit further, I would actually maybe even create this debit mutation on the other side and just have that send in with the event. That depends a bit how far you want to take this. The big thing is that this is no business logic. There is no if this then that or whatever. It's just update the internal state. And this may seem a bit weird in the beginning. Why do we want to do this? Why do we want to separate our business logic from our internal state change? And that is because then we can execute them independently of each other. This is very, very nice where the system comes back, is that, let's say you are applying historical events. Do you want to have your business logic being executed as well? I mean, say your business logic is actually sending out an email or doing a credit card transfer. You don't want to have that happen every time you load up the aggregate root from history again. So by separating the business logic from actually handling the updating of the state, you can update the state independently of executing the business logic. Another great example for this is, for example, interest rate. At a certain point in time, you made a transaction and you had to pay an X amount of interest on this. Interest rates fluctuate. But when you want to load this entity back up from its events, you need to know which interest rate at that time was being used for this transaction. You need to know all of this data which is fluctuating. But you don't need to actually reapply the business logic. You don't need to do a new calculation. You have all of the state changes within your event, and you just apply them back into the aggregate. Which also means that if you've got two events in a row updating the same thing towards two different values, then you have indeed, when you bring it back up, these two different actions happening in row as well. But that should be not a problem. Let's take a look at the base class, because I guess this is sort of clear that why we have this separation and how this works. So if we go to the register event in the base class, here you can see it's the event type, and I have an action, which is an event handler. and I add this towards to my local list of registered events with a type, which is a dictionary, and an action. Now this is a little bit of cool logic, again thanks to Jonathan, where if we apply an event from the history or from the internal apply method, I'm using the base interface iDomain event. But my event handlers, as you have been able to see, are very specific to the type of event that they handle. So I don't need to do casting inside here. And else, if I would have done this differently, my first approach was using reflection, which was slow, of course. Where this approach now, I'm basically executing, I'm making a new action, which takes this iDomain event, and within that action I'm executing the provided action, and within there the parameters I'm doing the cast. So I think this is a very elegant way of dealing with this without using reflection. You're only doing a cast, but it's a safe cast, because how this works, you cannot really put something else in there which doesn't work. So then we have registered them. Then let's go and take a look at the apply method here. This is where we actually publish or apply our event to our aggregate root. The very first thing is that I'm assigning the aggregate root ID to the event. I'm doing that here because I don't want to repeat the same logic in every place where I'm actually creating an event. And the next thing is here I'm assigning a new version for this event. Each event will have a new version number, so 1, 2, 3, 4, 5. This is because events, it's very crucial that they are actually being applied in the same order. Unlike working with a snapshot, where the snapshot is the only truth. Events, if you replay them in the wrong order, you get a completely different state. So the version is for one is used to make sure that the order is correct. Secondly, the version is also used for checking that currency is in order, that you're not, for example, you load up an aggregate root, you make some changes, in the meantime another process has loaded up the same aggregate root, made some other changes, and when you want to save your changes, you're not working with the same version of the aggregate root as that the event store knows of. So in that case you are going to have a conflict. In this case, what I'm doing is I'm just throwing an error, but you can be very nice about it. You can actually say, okay, if I have from my previous version only this event has occurred, and this event is not conflicting with the event that I'm trying to save with my state change. So these two different state changes are completely independent from each other. You actually may allow, you can do then resolve this conflict automatically. So versions are crucial in this type of architecture. Then after assigning these two, I'm actually applying the event internally. Applying internally means basically getting from my registered event handlers, which is this one, getting the event handler for this type of event, which will return me something, else it will throw an exception. And then this nice logic comes back into this, returns an action which takes an iDomain event, which internally is being translated to my specific event type, and it's being executed. So here is where the actual internal state of the domain gets set. And finally, after everything went fine, we say that this domain event is being added to the applied events collection, and then we are done from this point on. So we can do this several times, and our domain gets updated, new states and new behaviors being executed, and this applied events collection gets more and more events. Then we get to a point that we say, okay, now we want to persist our entity, our aggregate root. So when this happens, we are actually then going here, we say, okay, we commit the transaction, and the transaction will take every aggregate root, and it will go through each one of them, and it will ask for get changes here. So here we're actually returning the applied events, and we're concatenating these applied events with events that child entities may have generated. I, for example, have a list, created an example here. I have a client, and a client can have several bank cards. I made my bank card an entity purely for the example. And my bank cards may have particular behavior as well, which is publishing events. Now, when I get the changes, I also want to get the changes of all of my child entities. And I make that a responsibility for a base aggregate root instead of a responsibility from the repository or whatever. So that's what this is. And then finally, I'm ordering them by version. And this is particularly because if I, for example, have I trigger an event, the first event in my base aggregate root, then I trigger an event in one of my child's entities, and then I trigger another event in my aggregate root. The order would be completely wrong here. And I know that is something that you can have the database do as well, but since this is a write only, I want to write out my events in the order that they actually happened. And I know it's an anti-pattern to say that events should occur in a particular order, but I think that is something that is very crucial for the event store, as well as for updating the reporting database, since we are only updating the state changes. For example, if I change my balance, I withdraw money, 1,000 kronas or euro, and then I'm gonna add another 500. If I do that in a reversed order, then in this case it doesn't actually add up. But if I don't have the order correct, then my eventual state may be different than when I have my order correct. So the repository, yeah.
Mark, we have another question from Mike, and he wonders how do you test the root aggregate?
There's a very elegant way of doing that, which, if it's okay, I'll present afterwards.
Fine.
We are basically testing them as if it's a black box. The whole aggregate root is a black box. I'll show you after I get finished this. Get this finished. So if we go and take the domain repository, look at the interface, you can see that here this is very non-DDD domain repository, because many people in DDD wants to have very specific repositories for the very specific usages. But because the only thing that we really can do from our event store is getting an aggregate root by a particular ID, or adding a aggregate root, that's the only thing that we can do. We don't need specific repositories for the specific aggregate roots anymore. So that's why this looks the way it does. Our well-known domain repositories, you'll probably find them more on the reporting side. If you, for example, choose to use a ORM like an Hibernate on the reporting site, then you're probably going to make very specific reporting repositories there. instead. But on the domain, this is all that you really need. You need to be able to get an aggregate by its ID, and you need to be able to add the aggregate to the collection of aggregates. As I mentioned before, no delete. So we are actually
Mark,
yeah.
you have a question from Archel, and he wonders whether it's a bug in the event store identity map class at line number 23.
Okay. Let's see. Where?
Yeah, event store identity map class.
Line. Which line was it?
Number 23.
This one? Since it's returning null, or what would be the bug here?
He doesn't mention, so
Then we're going to skip that for now.
yeah.
I can say it's returning null because the identity map is basically a sort of a cache which is held. So when I'm requesting an entity here, I'm first checking whether or not this is actually in my identity map, and if that is null, then I'm going to my unit of work and requesting it from the event store. So depending on the lifetime of this identity map, you don't have to go to the event store as often. That's basically it, and I think that might actually be the thing that they were commenting on, but I'm not sure. But if we go to the event store unit of work, the thing is here is that I'm newing up my aggregates. So all of my T aggregates needs to have this constraint. There's in my case no need to inject services or anything into the if you want that, then you might actually want your IOC to new up the aggregates instead. Then the next thing that I'm doing is I'm checking if a snapshot exists. We'll go over that a bit later. And then I'm loading my historical events in my aggregate root. I'm not going to go and show you how I'm getting them from the database. Everybody can dream that by now, since nobody is using an ORM, right? Then here, this is the part that says, okay, register the aggregate root for tracking. So at this point, my unit of work knows about it, so when I commit my transaction, I don't actually have to have saved my aggregate root. This is here doing all of that. So this is how I'm getting it back from the event store. Now, if we are committing, because that's when we actually get our changes. So I'm committing, I'm starting up a transaction, then I go to each one of the registered event providers. I could make the naming better. And here I'm saying event storage.save. And save here will get all of the published events, all of the applied events, I have to say. They're not published, just they're only applied within the aggregate root itself. And I'm basically saving the event to the store. And finally, this is an important one as well. What I'm doing is I'm updating the version of the aggregate root to the same version as my last event. And I'm doing that because if I don't, then I trigger this one. And this is the safeguard for checking that another process in the meantime hasn't updated my aggregate root to a new version, and then I'm getting a version conflict because my aggregate root, my event provider, which is the interface, has a different version than the version that I'm getting from my database. and then I get a concurrency violation. Now this is the area where you might want to improve and say, okay, if I have this event and my last update was this event, they are not in conflict with each other, just change the versions of the events to be in sequence and do the update anyway. That's an optimization that you can do, making it friendlier on the client. And here I'm updating the version in the database again. So after I've done that, I'm actually publishing all of my events into my bus. So at this point, I'm actually sending them here. And that is still going on in the same transaction. Since I was using SQLite as my database, I had some issues with distributed transaction. So that wouldn't be a problem if you're using a proper database or a different event store with different transactions, and then your bus most likely is able to handle transactions as well for you. So this is really just starting the transaction, executing all of your database logic, and then publishing your events. And then the final step here is clearing the event provider from all of its events that have been applied, because you don't want to re-save the same events again. If you, for example, trigger some new business behavior on the same aggregate without loading it back from the repository, then you're just adding new events. Then only these events should be saved. And as you can see, this that get changes is sort of a dirty check that an Hibernate is using in the different ways. So this indicates, yeah, we have changes in our event in our aggregate route. Finally, I'm clearing my my unit of work register. I'm committing the bus and I'm committing the event storage. Now, you want to do this one first before you publish it out, because this one is least likely to go wrong. You want to do the stuff that is least likely to go wrong first, and then the stuff that is most likely to go wrong last. This is because you but instead of failing fast, you wanna get things done as much as possible, and then hopefully the last step will go fine. It's a personal opinion in my case, I think. So then we have actually we have published our events to the to outside of our aggregate route. So we really have done most of the things here. Unless there are some more questions about that, I'll show you how you can test that. This class has been stolen from Greg, or he gave it to me, which is a base class. Oh, were we? Okay, let's do a client moved.
Mark, we have a question from Andreas. Why care about the order if it's in an autonomous transaction?
The only real reason that I care about the order is that I really would like my events to go into my event store in the order that they appeared. And even though I'm putting my events in my bus here within a transaction, I'm not sure if that transaction actually goes all the way here and all the way gets to my reporting database. But anyway, if these events are not in order as they occurred, then even though they are in one transaction, they just are updating this database in a wrong state. There's a likelihood for that happening. if I change my name twice, I changed my name first to Mark Nijhof, and then I changed my name to be reversed Nijhof, Mark, right? So if I publish these events in the wrong order, then my reporting database will have Mark Nijhof as the final state, whereas my second event really is Nijhof, Mark. So that's why my events there needs to be in a specific order. But that is only for going to the reporting database. Events that go outside of that, go to a service, do other stuff, or their order may actually not be that important. And I think it's a very good practice that you make sure that order in that case is not important. That makes sense? Okay. Here we have a typical BDD sort of style test. We say this is the scenario, or whatever you want to call that. I've got a command test fixture. I specify the command, I specify the handler, because I can have, I don't know any good reason why you want to, but you can have multiple command handlers executing on the same command as well. One scenario that might be true there is if you have two aggregate routes that needs to be updated by the same command, you may actually want to do that in two different handlers. But on the other hand, you probably want that to happen in the same transaction, so yeah, it's up to you. And here I'm specifying on which aggregate route this test is acting on. The reason why I'm specifying all of these things is that I'm doing a little bit of mocking magic in the background, where I'm mocking the command handler, and I'm automatically creating a mock of my domain repository, which is returning this one. I'm actually not mocking the command handler, I'm mocking the dependency of the command handler, sorry. So here, let's step to the when first. I'm expecting a specific command. So this command is being used in the when with this type of information. When this gets triggered in each one of these thens, I'm newing up the command handler. I'm injecting the domain repository which returns the client. So all of the logic within the command handler is tested in this case. And I'm testing the actual aggregate, the domain, by just checking what types of events have actually occurred because I triggered this behavior. So instead of saying, okay, let's go and look inside of our aggregate routes and check if this bit has been changed, if that bit has been changed, and stuff like that, I'm really only interested in the events that have been reproduced by the domain. So there I can check actually that the published events is automatically being triggered, which is an enumerable. I'm getting my last one because I'm really only interested in the last one in this scenario, and I'm checking that that is actually of this type. In my next test, I'm actually checking that certain information has been published correctly. So from my command in here, I get correct information out again. So the domain, including the command handler, is seen as sort of a black box. I don't want to do anything there specifically. Another interesting thing is the given here. Since we can set state of our aggregates route by loading history, which basically means loading events, I can use the same in my tests. Since, for example, I want to run a test on an active account, so just newing up the account won't work. I actually need to activate it by using an event. A much better test for that, I'll pick it up, is again withdrawing cash.
Mark, Rob is asking what testing framework are you using here, and how did you get ReSharper to recognize it?
Well, let's the second question first. ReSharper is not recognizing it. I just disabled the annoying blue little line underneath the names here. I have trouble with spelling, but I rather have that trouble than having all of these annoying blue lines. I guess that's the second question. The first question is the test framework is really not an actual framework. It's a unit with a base class, and I'm going to show the base class in a minute. This is the success story for when withdrawing cash on an active account. And I'm saying here my given is that, okay, my active account has been opened, and that has this information. And then I have a cash deposit event, depositing 20 euro using one amount of 20 euro. You could also, for example, do it this way, where first one is balance, so 10. Okay, so you're bringing back the state of your aggregate root in the exact same way as you would do that normally. So you're not going in the aggregate root and setting some properties manually. So the only way this aggregate root can come to this state is by executing the events. So you're ensuring yourself that you're not testing something on an invalid state, because the only way it could get there is by having these events. Now, if you have these events, then that means that it is possible that they have been triggered in that way. Or almost. There's exceptions there. And I think this is a very powerful way of thinking, is that you are executing the exact same logic, the exact same things on your active account than when it is actually working in your domain. Now, you're not doing any side effects outside of your domain because there's nobody really listening to your events. So if you've got an event that says, okay, send this user an email, then since you're not doing anything on it, you don't have to worry about this side effect, which is another point where I think it's important to not do too much in your domain itself. Have a service deal with that, if that makes sense, or another something. So we bring back the aggregate root to the state that we want to test. Then we're executing this command. That command will actually then go through the command handler, which asks the repository for the active account. Then the main logic is being executed, and that should result in a cash withdrawn event with a particular balance, a new balance, because we had 20, we subtract 5 means 15, and the amount should be of 5. So these are very clear tests, and the cool thing is that if you keep these names somewhat very close to how the client is using them, then you can give this test to the client and he should be able to read it. And if that is not enough, the other thing that you can do is you can just, and I know MSpec is really good at that, is you can just print out this line and then have a given and print out all of these events. And then you say, okay, when this happens, so when we withdraw cash, and then you can say, okay, then this and this should be happening outside. So you can make it much more readable than your overall TDD tests. Whereas this is not actually, well, this is sort of homegrown. One other one, for example, a closed account. Here I'm testing on a closed account. That it should be opened first and then I'm closing it. That's how I get a closed account. Then I'm executing a particular type of command. I'm sending it, behavior gets executed, and I'm saying, okay, this should really result in an exception. So this is the exception that I expect. This is the message that I expect from it. I think this is a very interesting way of dealing with these types of things. This is the class that I'm using. And I have a few variants. I also have a variant that does the similar thing with presenters. So where I'm saying, okay, this view, this type of event has been executed, and then on the presenter something needs to happen, and then I'm checking, for example, if the presenter is actually sending out a command. Stuff like that. So interesting. If you want, you should take a look at it. A little bit of mocking magic here. I'm automatically mocking every dependency. But here, as I said, if the dependency is actually an iDomain repository, then I'm setting it up. I'm using mock-q here. I don't think I want to go into much of these details here. It will be much better if you just play around with it. But as you see, you don't need a big testing framework to get these nicer looking tests out. You can, of course, and I think it's a good thing if you start small with this, and then once you feel comfortable with this way of working, then you go and say, and taking it a step further and go, for example, to mspec, which is very nice and has many benefits, but maybe to just start, this is fine. And these are very specific towards how your domain works using events. So, are there any questions on this further? So, then we basically really here still. So now we have to take a look at how we actually update our reporting database. It goes in a very simple fashion, and that is got events here. For example, this one, account name changed event. And this event also has a event handler. Name changed event handler. And what this one is doing, really simple, is it's getting the reporting repository, and it says on this DTO, which is basically a reflection towards the database table, and on this DTO, on both of these, the account name. I'm sorry. I'm getting the correct where class by using the account name, and then I'm setting the no, I'm completely wrong here. I'm setting the account name using an anonymous object. Since this here is the same, resharper tells me that I don't actually need to use this, but this is really what's going on, and I'm selecting the correct row by using the aggregate ID. So if you come and have another view which also has an account name, and you and it is particular enough that you say, okay, this warrants its own DTO, you just need to expand these event handlers to also do that. That's one way. And another way is that you can just add another event handler to do this other thing. For example, if you have your reporting database, which this one is updating, and you have a star diagram database or whatever in another database which is being used for actual reporting as we know it, then you may actually want to split that logic up into different event handlers because they are particularly different. So then you have got two event handlers acting upon the same event. So this is not that hard, I would say.
Mark, we have a question from Ryan, and he wonders what's the performance hit from creating anonymous objects like that. Are you doing anything to get them garbage collected quickly? like in F#?
No. For the first question is I don't know. I went for a quick and dirty in this case. As you can see, this is sort of my own ORM. It's the very first that I've created, and every developer should create at least one, so they know why not to do it. So this is mine. So I don't know. I know Greg is using a similar way of working. He has only a very nice trick, and that is that instead of actually executing these SQL statements on the database, once they come in, he batches them up, puts them in a text file, and then either after an X amount of seconds have elapsed, he is executing them all in a batch, or when the first read request comes in, and then he appends the read request to the batch and executes the batch and gets the results, which is a very nice way of ensuring that your reports will always have the last known update, because there may be stuff in the pipeline, but that's not known yet by the reporting database, and still getting not that much performance penalties. So for this part, I would have to run some tests and read up on it. I'm not doing anything with them here. I'm not doing anything with garbage collection or something. It's mostly something that I didn't spend too much time on preparing the example.
We have one more question from Eve. How do you replay the messages to these denormalizers?
Replay them. For example, when you have an extra reporting need or something like that. Well, really, the thing is that I haven't covered snapshots yet, so I should do that as well. But what you do is you just request all of the events for this particular aggregate. You make sure that they're in the right order, and you publish them in the bus, for example. But instead of putting this in the bus that you use to update the database, you can put them in a different bus, for example, where you have a small application that instead of doing this all in a infrastructure, you just directly request all of the events from the event store for all of the aggregates that you want to report of, and you just have specific event handlers doing the other reporting logic that you need, and you just execute it. It's very straightforward in that way, I think. You need to think about it a bit, but it's not. I would personally take that outside of this whole process. And I don't know if you are, for example, have no updates going through the night, or you can stop this queue. Say you want an extra report side by side here. Then in the night you say, okay, I'm going to stop the queue. I'm not going to let any events go to the database anymore. You start replaying all the events from the event store for all of the aggregates that are affected by the new reporting needs, and you have a side process updating this other database until you've got all of the events that have been replayed here, minus the events that you have in the bus. Then you register these new event handlers in the bus as well, and then you start the queue again. They will update all of these changes here, and they will automatically also update these changes in the new database here. This is a very simplistic way of thinking about it, but I think that should explain it good enough. Hope. So, I mentioned snapshots. Snapshots are really a optimization technique. Consider you are running for a year and your aggregates now have 100,000 events in them. This will slow down anything that you want to do with the domain. So for that you create snapshots. And snapshots are basically sorry, created by an external process. You have a process running in the background somewhere which just loads up aggregate roots in a particular order or whatever, and this process will check, okay, how many events have occurred since my last snapshot, and if it's over a certain threshold, create a new snapshot. And what this does is it's using the memento pattern that we can actually go and see. So it's using the memento pattern to grab the internal state. So what it does, it requests the aggregate from the event store. The event store makes sure that it is up to the latest state, and then it says create memento. And what that then does, it's just capturing all of the internal state and puts that into one single object, and this object will be persisted in the database as well. Now, when the domain repository requests an aggregate root from the event store is first going to check, okay, do I have a snapshot for this aggregate root? And if I do have a snapshot, then I'm going to load this snapshot first. So in that case, using set memento. It's bringing back the state which is known from the snapshot. And after that has happened, it's going to request all of the events that have occurred after the snapshot. And then it's loading those events in the load history method, bringing the aggregate root to the actual last known state. So this is purely an optimization technique for speeding up loading aggregate roots from the event store. You would not delete any of the events prior to the snapshots, and you would only have one snapshot per aggregate root, unique aggregate root. So you wouldn't keep tracking, you wouldn't keep multiple snapshots of the same, just the last one, and get that state, load the state in, and you're done. Just going to look through here. I think, I hope that everybody sees that it may have looked somewhat complicated in the beginning, but I think it's actually quite a bit less complicated than doing it the original way, where you would just persist your whole domain using, for example, an Hibernate into a database and loading it back from there again, because now these events, independently of what type of aggregate root you're talking about, they all look the same because they are serialized in a particular way and they're being put into a event store. They have an ID and they have a type, and that's it. So there is no problem in persisting your domain anymore. There's no mismatch between object relational data and object-oriented data and your relational database. So that is very simple. And on the other side here, the read database, there you are providing tables specifically for your need. So when I have a table for one screen and another table for another screen, my select queries are going to be that simple. I'm not going to have to deal with a lot of stuff, and I'm not going to have to deal with an ORM. There, you would probably use an ORM, but you would use only like 20% of this ORM. You would only use it for reading. Another interesting scenario that I actually skipped over was, let's say I'm getting a money transfer. Yeah?
Can I disturb you once more? We have a question from Yves about the mementos and how do you deal with versioning and future fields?
Right. That would be needs to be dealt with within the within these two methods here. So you need to make sure that they are either before they're. You could do it in two ways, I guess. You could translate the old snapshot to a new snapshot. If you want that, but I think the most simple way of doing this is actually delete the snapshot from your event store. Just delete your snapshot and let your in the background process recreate one. This will take a little bit of extra time, so do this at a low traffic point in time, and all of your new snapshots are being created with your updated Memento. Versioning of events and is another issue, and there you would translate them because you don't want to delete the events and recreate them in some magic way. So let's say you've got an event and then you get a new version of this event. But when you're reloading the entity or the aggregate from your event store, you will still meet these old events. Now, instead of having your aggregate root know how to deal with the old event and the new event, and perhaps like 10 events later, all 10 of them, you would introduce a translation layer or sort of something in the middle where you have a sort of a decorator pattern or whatever. Say, okay, if this event is of this version, then I first need to translate it to this other version, and if I have 3 versions, I have 3 translations. When you have multiple versions, you might actually optimize it that you say, okay, everything from event number, from the first event to the 5th event, I know how to translate in one go. All the other ones go in between. So that is something that you need to spend a bit of time in on how to properly do this. That in the end, again, very solvable.
We have 2 more questions, one from Rob, and it's something we talked about yesterday, and he asks, how do you see this model working with an object backend storage like SimpleDB or Azure Tables or CouchDB rather than the relational? Also, SimpleDB already has the problem of eventual consistency, and now it looks like it could be eventual consistency times 2.
That's true. There's 2 things that I wanted to mention, and that is the eventual consistency that you can get between these 2, between the domain and the reporting database. And the other one is that what if your domain needs information from other aggregate groups? How do you do that by using a query back to the reporting database? So. The different databases, honestly, I don't have any real experience with document databases and object databases either, so a proper answer I can give you that. The thing is that you need to keep in mind is that the event store needs to be good at 2 things. It needs to be able to store events without ever altering again, and it needs to be able to load these events really quickly, depending on a particular ID and type. That's all it really needs to do. You're not going to do queries there. You're not going to do anything else there because all of that logic is actually in the reporting database. So I know that Greg, for example, created his own file-based database where just really quickly was able to read and write these things. The one benefit that we talked about yesterday, Jan and me, is that if you, for example, use something like CouchDB, where you serialize your events as JSON, then you can actually look inside your event store and see the different types of events and see what type of data they have, and you could do some queries on the event store as well. Although, as I said, I don't think that's the right place to do queries. I really think you should do the queries on the optimized database for that. And eventual consistency. Did I hear John wanted to ask a question? Or
there's one more question. It's from Arfiel, and he asks, if I need state from a different aggregate root, how can I request it?
Right. That one will be, I will answer that one after the eventual consistency question, if that's okay. If you, in my example, this whole process really runs in one process and is by definition is by definition consistent. As I said in the beginning, when you start with this type of architecture, that's probably where you want to start anyway. You probably don't want to introduce too much pain there. You run your event store and your read database on the same server together with your domain, and everything runs in one process, and you're happy. And then you suddenly start running into some performance issues, and that's an interesting thing with this. Since we have completely separated our reporting database from our domain, we can better pinpoint where our performance issues are and optimize that area. So if our read database or reporting database is running slow because we would have like 10 times more queries than we actually have domain updates in a system or whatever, then we can choose to split these two apart and have each one of them run on its own machine and introduce a queue in between. Now, in that case, you may run into some eventual consistency issues, meaning that your domain is updated to a new state, whereas your read database has not had that update yet. And I think that is something that you need to deal with a case-by-case scenario. How much time are we talking about anyway? We're talking about milliseconds in the beginning. When this is growing, until you say, okay, now we really get an issue in our client UI, the client makes an update and does not see this update, and he's annoyed by that. Then you could introduce the view model on the client, which you fake basically the results, similar as how many blogging engines do it. You post a comment to a blog, the comment is visible for you until you log into a different browser, and there your comment isn't available. It's the same way. And another thing is that since these are so separated from each other, you can actually start using multiple servers on this side, load balancing it, making the queue run faster again. So that's one way of dealing with it. Eventually, you may run in some conflicts, and that you need to probably deal with by case by case. If this update fails here on the event handler because you made some check that something needs to be in the database or a particular change, but it has been changed already, or it hasn't been changed, but the domain thinks it has changed because it has, then this one here throws an error. And in that case, you might actually want to go back to your domain and make a compensating action. An example there is usernames. Usernames needs to be unique within the system. When I, on the client, am entering my username, what I do is I request from the reporting database whether or not this username is valid. The reporting database says, sure, we don't have that one yet. Then afterwards, what we do is we send this new chosen username, which is okay, to the command. Then it goes into the domain, and I'm going to answer the second question as well. And then the domain needs to verify that this username is indeed a valid username. So what does the domain need? It needs information from the reporting database. So the domain could get a service, an external service injected using double dispatch, for example. And this service has one thing that it does, and it is just requesting usernames from the reporting database, or it's actually verifying that this username is a valid username from the reporting database. So that's also one way of how your domain gets knowledge of different aggregates or different types of aggregates. So it's in a sense it's all the report that you want to know. You want to know the state that is known, and this one is the authority of that. So then everything is still fine. At this point, before it goes in here, another user is actually doing the same process, and for whatever reason his event is being dealt with. He gets to the event publisher before the original user name request has been handled. So in the queue or in the process, we've got two events that indicate a username request with the same username. So the first one will go through fine, and the second one won't, because that username has already been taken. So what happens then is this event handler gets an exception. How you do that is up to you, but you know that something is wrong. And at that point, what you can do is you can have this event handler talk to a service, a domain service, which then either executes a compensating command, meaning that, okay, just generate a username for me which is valid and try this process again, which is very likely to succeed if you are doing a random generalizer. Or at that time you could perhaps even update the read database with some other information. You change the domain, you do a compensating command for the domain, resetting the username to a default, and you let the client know, okay, you need to actually choose a different username. And this is an issue only if your queue here takes a very long time or you have a huge amount of traffic. So I think this is again something that you should start dealing with as soon as you start getting these issues. Does that make sense? And did I also answer the second question enough about how the aggregates get data from the reporting database or get data from other aggregates? Assume the silence means yes. Unless there are any other questions, I think I've covered much of it. I would really suggest that you download the source from my GitHub repository, which is also mentioned in the blog post, and start playing with it. I think it's a very interesting style of designing your application, which has a lot of benefits. Think only about you've got an automatic audit log as well now. Another benefit, for example, is if you have multiple teams. This is where you want to have your smart guys working on. This is the important stuff. This stuff here and the client, not that important. So you would have some less smarter or cheaper people working on that. And the only thing that you really need to communicate, except maybe for how you want this client to look like, is your commands and your events. Those are your contracts between the two different sites. So if the guys in Poland or wherever know, okay, we can expect these types of events and this needs to happen with them, and we can use these types of commands. They can work independently from the people implementing this logic in the domain, where the real knowledge and real value lies. So I think that's an interesting aspect as well from a business point of view. Play with it, and you will. I think you will enjoy it. I think that's for me. That's it. If there's no other questions.
All right. Thanks, Mark, for all your efforts and a really nice presentation here. I guess we're going to wrap this up for today. I guess if there are more questions, you can always contact Mark, I guess.
Yep, absolutely. Go to the About page on Elegant Code. Everything is there, except my phone number. But you can ask that in a tweet or in an email. Thanks for having me.
Right. Thanks again, Mark.
Yep. Bye.
Bye.